This is how the U.S. built one of human history's most incredible engineering projects, the Panama Canal. Hewn from nearly 50 miles of jungle and mountains in the Panamanian wilderness, is the fastest and most direct link between the eastern and western hemispheres. And though the Panama Canal today is a booming economic venture, it was not without its cost. At over $50 billion adjusted for inflation and nearly 6,000 lives lost, the Panama Canal remains the most expensive and deadly engineering project ever undertaken by the United States. But why was it needed? And how did the U.S. solve what everyone else said was impossible? Before explaining how the Panama Canal was built, it is important to understand its need. After all, the prospect of blowing up and moving over 100 million tons of rock and earth, fighting rampant disease in an inhospitable environment, and doing something never done before required a very good reason. And there are a few. The first reason why was money. Before the advent of the Panama Canal, the main way ships got from the Atlantic to the Pacific and vice versa was having to go all the way around the tip of South America through the Drake Passage. However, the Drake Passage is notoriously rough. Due to the convergence of the Atlantic, Pacific, and Southern Oceans, the Drake Passage can routinely see swells of over 30 feet tall and extremely high winds. These dangerous weather conditions have caused countless ships to be lost at sea. And besides being dangerous, it added over 8,000 miles to a journey that could take an additional 5 months in the days of sail. While the Spanish and British were both interested in the project of developing a canal across the Panama, it was only in the California Gold Rush of 1848 that America really got interested for the first time. However, carrying cargo and passengers over land was still treacherous and time-consuming. That is when the U.S. Navy got involved. During the Spanish-American War, several U.S. warships had to travel all the way around the tip of South America from California to Cuba. The trip took 66 days and prevented these ships from participating in most of the fighting before the war was over. At that time, President Teddy Roosevelt was a big believer in having a strong navy to win influence across the world. With Teddy Roosevelt's ambitions of gunboat diplomacy and big business seeing an amazing opportunity funded by the government, all parties became interested in the project. And it just so happened that the French allowed the U.S. to do so. The French had officially began construction of the canal in 1881. Fresh off their successful venture to create the Suez Canal, a nearly 120-mile-long waterway that connects the Mediterranean to the Middle East, the French government decided they could do the same thing they did in Egypt. But there was one problem. Unlike in Egypt, the building environment was completely different. In Egypt, the problem the French had to contend with was just a dry, flat desert that went from the Red Sea to the Great Bitter Lake and then to the Mediterranean. And though the French had many issues with ensuring water and supplies were brought to the workers, the project itself was very straightforward compared to what Panama had in store for them. In Panama, the isthmus the French decided to start excavating was a dense jungle inside one of the tallest mountain ranges in the Americas. The mountain ranges, along with the Continental Divide, cut right in front of the Miraflores Lake, where the French wanted to connect the canal. The French decided that the best approach would be to build a sea-level canal. This meant that when ships approached from either the Atlantic or Pacific sides, the ship would be at the same height from ocean to ocean. But there was a huge problem. In order to make that idea work, the French needed to blast and move through literal mountains. The difficult work was made worse by the old, outdated, and underpowered equipment the French brought in to do the job. Over the next 18 years, the French tried in vain to dig the canal down to sea level. However, after hundreds of millions of dollars spent and over 22,000 lives lost to disease and accidents, the French venture went belly up in 1899. Seeing an opportunity to pick up where the French left off, The U.S. bought the remnants of the French venture for $40 million in 1904 after several years of political maneuvering and outright military intervention in Panama to secure leasing rights to the canal. Once U.S. engineers arrived in Panama and saw the state of the landscape, the U.S. decided that the best idea was not to build a sea-level canal, but to build a system that could lift ships up and over the mountains. But how would the Americans do this? Once American authorities had decided that the best path was to go up instead of through the earth, they had to figure out how to create the mechanism. This ended up becoming the famous locks the canal is known for. But what are they? Situated at either end of the Panama Canal, from the Atlantic side, there are a series of 3 locks. On the Pacific side, there are 3 more sets of locks for a total of 12 that can allow traffic to flow in either direction. These locks are massive blocks of steel-reinforced concrete that are 110 feet wide and 1,050 feet long. Their purpose is to lift incoming or outgoing ships a total of 85 feet above sea level. But how do they do this? Once a ship enters the dock, there is a gate that swings closed behind it. At the bottom of the lock, there are more than 100 separate openings that allow water to flow into the lock. In just about 10 minutes, the lock fills with 26,700,000 gallons of water and lifts the ship up to the next level. How the ship is able to stay level despite differences in displacement is thanks to the law of communicating vessels. This basic physics principle states that as a container is filled with a homogeneous liquid, such as water, the vessel, in this case the locks, has an even level of water between the two of them. This is because very small gaps in the bottom of the gates link the docks together. But why? Due to the immense forces of the water acting on the gates, the miter gates, as they're known, are no ordinary doors. First designed hundreds of years ago by Leonardo da Vinci, the miter gates in the canal are massive steel doors that are between 47 to 82 feet tall, depending on which part of the canal they're in, and they are 7 feet thick. Held together by more than 6 million rivets and weighing in at hundreds of tons each, their hinges coming in at 14 tons each, these massive gates are a key part of the lock system. Their main purpose is to hold back water from the other locks as the current lock is being filled or drained. The gates form a unique V pattern that creates a stronger seal as the water pressure increases. At the bottom of the gates is actually a small opening that allows some free flow of water in between the locks. This does 2 things. It keeps the pressure off the gate hinges and makes the gates partially buoyant and easier to open. However, because of the construction of the locks, there was a limitation on the size of the ships that could transit the canal until recently. Known as the Panamax limits, these dimensions were the maximum length, width, and depth of a ship that could safely transit the canal. While the old dimensions were no problem for decades, larger and larger cargo ships being built facilitated the need for Panama to increase the lock size. Finished in 2016, these new locks can fit so-called Neo-Panamax ships that are several hundred feet longer, about 50 more feet across, and 10 feet deeper than before. But where do the locks get all their water to allow the vessels to transit? Remember when we mentioned that there was just one lake when the Americans arrived? Looking at a map today, there are 2 lakes that make up the canal. However, the larger one, Gatun Lake, was not there when work began. But why would the Americans decide they needed an artificial lake? The nearby Tigris River was a powerful river that often flooded 30 feet above its floodplain during the rainy season from May to December. Because of these frequent floods, it was decided to use the local topography to their advantage to shave years of work off the project by damming the river to create a lake. Doing so had a few benefits. The first of these benefits was that by creating a man-made lake, the Canal Authority would always have a steady supply of water going into the locks, since about 50 million gallons of fresh water is lost to the sea every time a ship goes through. The canal could operate year-round by having water available even during the dry season. The second main benefit was that the project could move along much faster by flooding the surrounding area. Even with the 95-ton steam shovels that could fill an entire rail car worth of spoil, that is, rock and earth blown up by dynamite, in about 8 minutes, the work was still very slow going, despite, at times, there being a train coming or going every minute. Every mile of the transit that did not have to be dug out of the earth saved countless dollars and lives. But how did the team build the dam? The narrowest and most difficult part of the Panama Canal is known as the Culebra Cut. This man-made pathway connecting Miraflores Lake to Gatun Lake was the most challenging aspect of the construction. But why? Building upon the French idea of essentially making a giant ditch through which vessels could navigate, the U.S. began excavating a nearly 8-mile channel through the Culebra Mountains. While initially planning for a narrower channel, the project ran into a snafu they weren't expecting. During the rainy season, the clay became like thick mud and was incredibly unstable. There were frequent landslides that destroyed equipment, killed workers, and wiped out sometimes weeks or months' worth of progress. However, while landslides during the rainy season were to be expected, it was not expected to see them during the dry season. But how? Due to the unexpectedly weaker rocks at the bottom of the proposed cut, as the workers began digging into the mountains, there were frequent landslides where the top-heavy ridges gave through and contained more dense rock. As a result, the Culebra Cut had to be dug more than twice the original width to create a very gentle slope to avoid further landslides. But where did all these millions of tons of rock and earth go? While some of it was taken by rail to be thrown into the ocean to make breakwaters or just thrown into the jungle, a good bit of it was used to build the dam for Gatun Lake. The Americans built 2 walls 400 meters apart of blasted rock that were then filled with countless tons of earth and clay. As this mixture dried, more rocks from the Culebra Cut were thrown on top and the process continued. This work continued until October 9, 1913, when the Americans completed the Culebra Cut with a bang the next day. On the afternoon of October 10, 1913, thousands of canal workers stood by on the shoreline watching in awe. In the Miraflores Lake, there were hundreds of their fellow workers in canoes. Mixed in the crowds of men were dozens of locomotives, tugboats, and dredges that dotted the landscape. But what were all these men waiting for? Nearly 6,400 kilometers away in Washington, D.C., President Woodrow Wilson was sitting at his desk. Once he had received word that the time had come, he pressed a button in his office that sent a telegraph signal which took 4 seconds to reach Panama. At 2:02 that afternoon, 8 tons of dynamite blew up the Gamboa Dike, the last obstacle holding up the Culebra Cut. At that moment, tons of rock and dirt flew into the air as hundreds of canoes rushed into the now completed Culebra Cut, the first vessels to actually enter the canal. This moment, meant to show just how far mankind had come in technological advancement, was spectacular. Though the canal itself would be open for the public in August of the following year, it was a moment of celebration for just how far the canal had come and what had been accomplished. Bye for now.